A loop of r equals 3 sine 2 theta. Let's just do a quick sketch of this then. Try and get a loop of this and work out the area then. So sine of naught is naught. Okay, and then 45. Can you see at 45 is going to be maximum, isn't it? So this will be pi over 4, or 45 degrees. And when you put that in, you get 90. Sine 90 is 1, so we get 3. It's minimum at 0 because it goes round to naught. So it looks like it's going to go like that, doesn't it? Agreed? So let me just try and draw that a little bit more civilized. Like so. So that was up to 45, and then it's going to go from 45, and at 90 it's going to be sine 180, which is naught. So it's going to come around and be like so, isn't it? There's a loop. This curve here, isn't it? So we can go from 0 to pi over 2 when working out this area. So let's do that then. So here, the area in question of a loop is equal to a half the integral of r squared d theta between 0 and pi over 2. So let's put the values in. We could do 0 to pi over 4 if we wished, and just do double. Oh, it doesn't matter, this is fine. So it's 0 to pi over 2, and r squared will be 9 sine squared 2 theta. Double angle formula here, so we need to remember that. 9 sine squared, we've squared this, we've got this. So it's 9 lots of, put the 9 there. Now I'm going to need a 2 underneath. So I'll put another 2 there. So that I can carry a 2 in here with the sine squared. Right. And that will be then 1 minus cos 4 theta. Won't it, using the double angle formula for 2 sine squared x, and the x is 2 theta. Okay, so I think that's it. So the 2 sine squared is 1 minus cos, double the angle, yeah, that's fine, d theta. So what have we got then? Well, we've got 9 over 4. Let's integrate term by term. 1 integrates to theta. The cos integrates to sine with a minus. We'll need a quarter so that the 4 will cancel when we differentiate the sine 4 theta to get us back to the cos 4 theta. So that's what we've got. The good thing about this is both the top and bottom values for this thing here are 0. So we're simply left with the values of theta. So that's equal to 9. Because that one's a 0, we can just put theta in as pi over 2 as the top value. So it's 9 pi over 8. Just over pi. If we go back to our sketch here, you'll see that's a distance 3. And here's our loop. So if you think about a circle, 1.5 is 3 over 2 squared is 9 over 4 pi r squared. 9 over 4 pi, 9 over 4 pi is the circle, and we've got 9 over 8, so it's squashed somewhat, isn't it? It's half the area of the circle. So it's quite squashed, isn't it, when you think about that? Okay, good.